Hey, this is Joe at Gray Bench Electronics. Welcome back if you've been watching the tube amp build series. We last left off, we got the drill template attached to the chassis. So the goal of today is to punch out the drill marks so we know where we're drilling our holes, and hog out all the chassis bits to make room for the Z-mount transformers as well as the can capacitors, and also drill our holes for our tube sockets. So let's zoom in here real quick. I want to show you a little more marking that I did on this template, and then we'll get started drilling. Alright, so I didn't show this on the last video, but what I'm doing is I did the original layout with the power transformer pushed down towards this bottom edge because I was concerned that I wasn't going to have room for the lamp that I want to install as well as the power switch. Also, I'm not doing a standby switch on this amp. I generally don't do standby switches on amps with tube rectifiers. But I thought I wasn't going to have enough room, so I pushed the power transformer down. But I think it's going to be fine, and more importantly, I don't think it would be fine for the fuse holder, which I want to install at the bottom here. This would have hit the bell if we had the power transformer down this way, or at least been too close for comfort. So I think it's going to be okay if I just center the power transformer on the chassis. So I made those marks and I translated that over. I also did markings here for the cutout for the bell of the transformer. So the transformer here is going to be Z-mount, which means that it's going to sit with the iron here flush to the chassis, which means this bell is going to be sticking up through the chassis, which means we need to cut a hole out for that. So that's what I did. So I had my original marks for the bolt spacing. I drew in a rectangle 1/4 inch in on each side, and then made a rectangle out of that. That's going to be my actual cutout. But I want the corners of that cutout to be rounded. And it's good to be rounded because, one, you won't get as many stress risers at that corner as if it actually was a sharp, like 90-degree corner. Also, rounded just looks nicer, and most importantly, rounded corners means we can drill holes with a standard twist drill bit in those 4 corners, and that will then give us the ability to cut straight lines from corner to corner to cut out the whole rectangle. So after I drew that 1/4 inch smaller rectangle inside, then I drew another rectangle inside 3/16 in from that inner rectangle, and that gave me the radius of a 3/8 drill bit. So I have a rectangle there. The corners of that second inner rectangle became the drill marks for 4 3/8 holes, which I'll then use probably a rotary tool to cut a straight line for each of those drill holes, 3/8 drill holes, which will give me my radius rectangle on the inside. So next step is punching the drill holes. So what we're doing first off is we are going to punch the drill holes for the chassis here. I'm going to use this automatic center punch, which is just a spring-loaded tool that puts a dent into the chassis. And the reason we do this is so that when we're drilling, especially like this, I'm going to be freehand drilling, our bit is going to find that divot, that little dent in the aluminum, and help me guide the drill bit in because I'm doing it by hand. This is a must-have tool if you're going to be doing, hand metal work. But a word of caution with these is they are deceptively loud, so make sure to wear hearing protection when you use really any kind of punch, but especially an automatic center punch. It's got my hearing protection on, so I'm going to make sure that my template here is laying nice and flat. Come in here, find my drill mark, I should say my crosshatch where I'm going to be drilling, make a punch. Come into the next one, make another. Okay, so now I got all my drill markings center punched. We can pull off the template. going to hold on to the template because you never know. Might want to use this or reference it at some point down the line. So I'm not just going to toss it. But so now I can see my drill holes. Boom, 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 all there. What I like to do, just so I know that I don't lose them, so I like to come in and circle them. Cool. So then we have all the drill holes marked. Okay, so we got our chassis all punched out. I go and just write the size of the drill holes that I'm drilling, just so I don't get confused. So next step is drilling out these holes for the transformers, for the tube sockets. Always start with like a starter bit of like 1/8 inch or so, and then use your preferred method of making bigger holes. Okay, so I'm gonna start drilling out this chassis. Obviously, some sort of drilling machine like a drill press would be ideal for this, for making orthogonal cuts into a flat piece of metal. But I don't have a drill press big enough for this chassis, so we're gonna hand drill it. I don't have a ton of tips for hand drilling or hand machining, with the exception of that you want to be as drill press like as possible. So that means making sure you're holding your drill press nice and 90 degrees to the workpiece, assuming that's what you're doing. And with metal, it's about pressure, not about speed. So I have my drill on the lower speed setting, and I'm just going to try to apply nice, consistent downward pressure. Not enough that it slams through to the table once we actually get through the chassis, but just consistent, even downward pressure. Oh, also, I have a nice fresh drill bit on here. That's always worth it. You know, it's nice to start with a fresh drill bit. You know, it's worth it for your whatever $100 chassis or whatever you had paid for that, going into an expensive amp. You know, spend a couple bucks, get yourself a nice fresh drill bit. Okay, first hole, let's do the rest. This is the important part about the automatic punches, is it gives me a little divot so the tip of my drill bit can find that easily. It doesn't want to walk. All right, so got all the holes for the different components and whatnot drilled out, at least the pilot holes. So now we're gonna start expanding these open. Yeah, so these are stepper bits, and they give you a range of sizes. They also just leave a nice clean hole when you're done. So we're drilling out these inner holes that are gonna be the corners of the cutout for the bell of the transformer. We're drilling those to 3/8, and I have that on this piece here. So we're going to drill these out. So that's the inner corners here. We're drilling these to 3/8. Which is the first step here. Same thing over on this side. So I got those bigger holes drilled out. Oh boy. Well, you know, it doesn't always go to plan all the time. So unfortunately, I made a mistake here and drilled the smaller hole that was for the bolt mounting for the transformer. I drilled that out to 3/8 instead. So that was an oopsie. Let's see what we're going to do about that. So I can use a little bit of spacer in there just to try to make up the difference, or I'll use some washers for the transformer. But I want to make sure if I still drill out this middle 3/8 hole, if there's still going to be enough metal there. Yeah, that's okay. All right. So, unfortunate mistake, but luckily it's pretty much going to be hidden underneath the corner of the transformer, so you'll never see that once it's finished. And also, it's not really going to affect the structure. We got 3 other bolts that'll be grabbing nice chassis, so let's just drill out this correct hole to 3/8. Okay. Still got a decent bit of metal in between there, so not too worried about that. And then for the bolt, we'll just get a nice washer under there with a bigger lock ring. That'll be fine. But, you know, mistakes happen. And if I was going a little slower, paying a little more attention, maybe could have avoided that mistake. But you take what you get, and I think this is the case, it'll be okay. So I wanted to show off this tool. This is called a deburring tool. And it's one of my favorite tools. In this case, it's Glow Burr is the name of that tool there. And it's just got a little single edge blade there, right hand turn. And all it does is it cuts off the burr left behind on drill bits. And it's an awesome tool. Another thing you could use if you don't have this, you could use like a chamfering bit on your drill. But sometimes this is easier to get into than a big drill, easier to get into the chassis than a large hand drill. So yeah, so you just take this, go into, here you see the, hopefully you can see that there's a bunch of metal going around there that's pokey and potentially could flake off and cause a short. So you want to clean up these holes. So you just take your deburring tool, come inside to the hole, even pressure, just spin it around. Make sure to turn right, clockwise turn. That, and then hopefully you can see that now that those inner holes there are nice and clean, no more sharp bits. So I'm going to do that for the rest of the large holes here. Okay. So we got the inner corners now drilled for the cutouts for the bells of the transformers. The next step is we're going to use some sort of tool to cut straight lines tangential to these 4 circles. And that will give us our radius rectangle for the bells of the transformers. That stepper bit leaves a pretty nice edge because what happens is as you're pushing down, you know, you slip a little bit and basically it chamfers it going up to the next side of the stepper bit. It's effectively just like chamfering it. All right, so next thing is we're going to scribe or mark straight lines between the outer edge of these 4 circles. Doesn't have to be surgical because my cut definitely won't be surgical, so just make a straight line just as a guide. So, got the rectangles marked, and now I'm going to use a Dremel or a rotary tool to cut those out. Alright, so got my Dremel with a cutting disc on it, and I'm just going to cut along these straight lines to give me a radius rectangle. Oh, also, safety first. Wow, it's taking a long time. Okay. Okay, so we got the cutouts done, clean up the edges a little bit. Here's our removed panels. So, moment of truth. It's gonna be the first time I've attempted to put the transformers in the chassis. Let's see if they fit. There's the output transformer. Hold your breath. Count to 10. Just kidding. Actually, should be going in like this. Oh, it's close. Very, very close. Come on. Yeah, just needs a little bit, but almost there. Exceptionally close. Happy with that. Okay. And power transformer. Oop. All right, here we go. Oh yeah, nice. All right, I just went and drilled these holes out from 3/16 to 5.5 millimeters. Let's see if we fit now. Yeah, beautiful. Cool. Okay, so we successfully have the transformers now Z-mounted to the chassis, like so. Drilling that went relatively smoothly. We still have to make the larger holes for the can capacitors and the tube sockets. We also have to drill holes for the fuse holder, output jack, input jacks, potentiometers. So we're going to break this up and we're going to do a drilling part 2. And I might investigate a different way to make these holes here. So if you're interested in seeing that, feel free to hit the subscribe button and hit the notification bell so you know when I post part 2 of the drilling series. And if you enjoyed this video, I'd appreciate hitting the thumbs up button. So again, my name is Joe from Gray Bench Electronics. Thanks for watching.